All right, welcome to the last unit of the year. And so we're going to kind of step into a section on systems of equations. We're going to start by graphing linear equations. So all these things are going to be lines, which should be pretty familiar with what we've done already. But we'll add some nuance to it with having some nonlinear graphing that we'll do. And eventually we'll move into inequalities that we're going to be graphing systems, and then we're going to go to matrices to end the year. And so today it's just going to be kind of remembering how to graph lines and then putting a couple of lines on each graph and then seeing where they might intersect. And so that's the goal of today. And so quick reminder of a little bit about graphing, right? We got y equals mx plus b is the equation for a line. We got slope is what m represents. Remember, we got rise over run. Okay, and rise over run is going to be based off of my change in y over my change in x. Right, b represents my y-intercept, so it's going to be 0b, whatever that value actually is. And then just a couple of points there as well. And remember that a vertical line is going to be an x equal equation, and a horizontal line will be a y equals equation, which hopefully from the previous unit with doing asymptotes, we've gotten a little bit better at identifying those things. So, all right, so a couple things. A system, okay, is a set of two or more. So most we're going to deal with is three. So we'll do two for a few lessons, and then we'll hit three. And they use the same variables, okay? So whatever variables, whether it's x and y or three other different types, they have to have the same kind of set of variables within each of those separate equations. So a solution, okay, is an ordered pair. Remember, that's just an x and a y, okay? That makes all equations true, all right? So that means that it is an ordered pair that if I put it in any of the equations that are given to me, it would be a true statement. And you're going to see that as we check some of these here. All right, so first thing, solve by graphing, check your solutions. Let's take a look at A. All right, so let's just identify some things here. At the start, right, my slope, my m, is going to be -1. Okay, that +3 tells me that my y-intercept is going to be 0 and 3. All right. And then my slope down here is going to be 3 over 2. Okay, my y-intercept is going to be 0, -2. All right, so I can use each of those things to graph. All right, so let's start with that first one. All right, let's start at the y-intercept. We got 0, 3. So that first one is here. Then it's -1. So we have -1. It's going to be rise. So we'll go down 1, then over 1. It's going to have a negative slope. And so plot a few points here. And then I can draw a line that hopefully goes through those relatively well. All right. And so that's the first one. Let's do a different color for the second one. All right. So we got the y-intercept is 0, -2. So that's going to be down here. And then we have a positive 3 over 2. All right. So we're going to go up 3, 1, 2, 3, over 2. All right. We see one there. 1, 2, 3, over 2. All right. So I got a few points. I can draw that. It goes relatively accurate there. All right, so what we are looking for when we graph these systems of equations is that part right there. All right, so the point of intersection is the solution. All right, so if I had to write that as an ordered pair, I go over to the right 2, up 1. So that's going to be 2, 1 is my solution. All right, and so if I wanted to check that, okay, I would take the equations. All right, I got y equals -x plus 3. And so if I put those values in, so that's -2 plus 3, that should equal 1. It does. So that checks off. All right, if I have the other equation, that's going to be y equals 3 halves x minus 2. So if I put in, all right, 3 over 2 times 2, okay, that becomes 6 over 2 minus 2, which is just 3 minus 2, and that does equal 1. Check. All right, so my solution is at the point of intersection. All right, so this would be 2, 1. That's my solution. All right. Let's try another one here. All right, so we'll use red again. I got m equals 2, and then I got 0, -1 for my y-intercept. All right, now here, I don't have y by itself. So in order to put it into that form, I'm going to have to rearrange. So I'll subtract 3x, and then with negative y equals -3x minus 1. Okay, I'm going to just multiply each side by -1. And I'll end up with y equals 3x plus 1. All right, so then my slope will just be 3, and my y-intercept will be 0 and 1. All right, so let's plot these. All right, so I'm going to start at 0, -1, and then I got 2 over 1. So 2 up over 1, 2 up over 1. All right, so I got 3 of these. That was actually bad. All right, so 2, there we go. That was better. All right. I got 0, 1. So that's here, and then it's going to be 3. So 1, 2, 3 over 1. All right, and I can go negative for each of them. It's negative divided by negative is a positive, so it's the same slope. 1, 2, 3 over 1. I got 1, 2, 3 over 1. All right, so if I extended that, it would actually go through that line. All right, so see our solution is right there. So we get -2, 1, 2, 3, 4, 5. So -2 and -5. All right, if I had to check those real fast, all right, I'll do y equals 2x minus 1. So I got 2 times -2 minus 1 gives me -4 minus 1. That gives me -5. Check. All right, if I got my other equation, y equals 3x plus 1, plug 3 by -2 plus 1, that's -6 plus 1. Does that equal -5? Sure does. Check. All right. So my solution is -2, -5. All right. All right. Let's try a couple more here. All right, so I got my slope is going to be -1. And if I have no value for my y, then my b is 0. So that means that it's at 0, 0. All right. X equals 5. All right, that's just going to be vertical. So why don't we just start with that one right away? 1, 2, 3, 4, 5. Let's go right down this line. And then starting at 0, 0, give me -1 over 1, -1 over 1. So go. All right, point of intersection right there. So I got 5, 1, 2, 3, 4, 5. So I got, all right, 1, 2, 3, 4, 5. Yep. So -5. No, +5, -5. All right. So if I put those solutions in, all right, I put it y equals -x, put 5 in for that, -5 equals -5, check. If I put x in for x, 5 equals 5, check. All right, so we're all good. All right, solution is 5, -5. All right. All right. Take a second, pause the video so you can try rearranging and graphing these things on your own. And then when you get a shot or get stuck, unpause it and watch. All right. So easiest one here is to convert this to y equals x plus 6. And then over here, I'm going to rearrange some things so I know what -2y equals -2x plus 4. All right, divide by -2. I'm going to end up with y equals x minus 2. Okay. All right. I'll rearrange that. So, all right. So again, my slope will be 1. And then I got y-intercept 0, -2. My slope will be 1. I got 0 and 6. All right. So let's start 0, -2. And then I got a slope of 1. So it's going to just kind of go right up along there. Keep going. And then I got 0, 6, 1, 2, 3, 4, 5, 6. Same thing. All right. So hopefully you recognize that, right, these things are parallel to each other. Maybe you thought that was the case beforehand because we got the exact same slopes, all right, which means that they're going to be parallel. And so the same slope means the lines are parallel, hence they will never touch. All right, remember this from geometry, that little dot triangle means therefore there is no solution, right? They don't intersect, so there's no solution that'll satisfy both of these. And so we are good there. Okay. And so this is telling you to enter these two equations, y equals 3x minus 1 and y equals -2x plus 1 into your graphing calculator. All right, and then for a second trace, number 5, and then enter 3 times, and you'll actually be able to see that. All right, so let's do that together. here we go. All right, y equals, I don't want to grab that right now. All right, cleared out. And so we got 3x minus 1. Okay, that's... There we go. And then we got negative 2x plus 1. All right. So we got two things that are not nicely on a whole number ordered pair. And so if we go second trace, you'll see number 5 is intersect. I can press intersect. It's asking me to find that point. Enter. And I get that intersect at 0.4 and 0.2. All right, so my solution is that 0.4 and 0.2. All right, so we could quickly graph that. And so we got 0, 1. We're going to go up 3 over 1, up 3 over 1. So all right, and then we got plus 1, and it's going to be down to over 1, down to over 1. And so, right there. All right, so we can see on the graph as well that that point is not nicely through point, which is why using the second trace intersect will allow you to get that exact answer of where they intersect and have your solution set. All right, so we just did some graphing of stuff we've done before where they intersect. That is solution. All right, so be able to graph these things properly, be able to plug values in and check. Okay, and so as long as it's true for both of them, okay, then you could be confident that you've got the correct solution. All right. Be sure to try this in your calculator because that will be helpful. All right, we're going to move on to this on Wednesday and Thursday. And so systems, but using algebra to calculate them and not graphing. All right, so trying to get the solution of that. So there's a system and a process, 2 different methods, which we'll walk through that in detail together when we meet next. All right, guys, have a great day. See you when I see you.